If you're building with AI, you've probably spent hours, maybe even days, perfecting your prompts. But what if I told you that's just scratching the surface? Today, we're going to dive into the next big thing, the real evolution here, moving from simple prompt engineering to the much bigger, much more powerful world of context engineering. And really, this whole shift starts with one fundamental question. Is just writing good prompts really enough to build the kind of smart, capable AI agents we're all dreaming of? Well, the answer pretty clearly is no, not even close. We've got to think bigger. So let's get a clear definition here. On one hand, you have prompt engineering. Think of that as the discrete task of writing and organizing instructions for one specific outcome. It's like writing a single recipe. But context engineering, on the other hand, is, well, it's the whole kitchen. It's the ongoing, iterative process of managing all the information, every single token, that the model sees during its thought process. It's a much bigger game. All right, so here's the game plan for today. We'll start with this big idea of moving from prompts to context. Then we'll dig into the core problem, what I call the finite attention budget. After that, we'll look at the anatomy of what makes context work, how to manage it over time, and we'll wrap up with one big guiding principle to take with you. So let's dive right in. Why is this whole context engineering thing so incredibly important? Well, it all boils down to one fundamental constraint of pretty much every large language model out there today, their finite attention budget. And this limitation, it leads to a really interesting problem that engineers are calling context rot. It's a bit counterintuitive, but basically, the more information you try to cram into a model's context window, the worse it gets at remembering any single piece of it. It's a classic case of more isn't always better. And you can see that effect right here. When you give the model a small, super focused set of information, its accuracy is high. It knows what to do. But as you just keep piling on more and more context, that performance can drop off a cliff. The model it gets lost. It loses the signal in the noise. You know, the best way to think about this is to compare it to our own brains. We have a limited working memory, right? You can only juggle so many ideas at once before you start dropping things. Well, LLMs are exactly the same. They have a strict attention budget, and every single piece of information you give them, every token, costs them some of that budget. And if you're wondering why this happens, here's the quick technical breakdown. It's all because of the transformer architecture they're built on. For every n tokens you feed it, the model has to track n-squared relationships between them. So that complexity just explodes exponentially as you add more tokens. It stretches the model's ability to keep track of everything. And on top of that, most of these models were trained on shorter bits of text, so they're just not optimized for super long, rambling contexts. Okay, so we've established the problem, this limited attention budget. Now let's get to the fun part, the solution. What exactly are the building blocks we need to create truly effective context? It really comes down to 4 key components that we need to actively manage. First, you've got your system prompts. Then you have your tools, the examples you show the model, and of course, the ongoing message history. Let's kick things off with system prompts. Now, the goal here is to find what I like to call the Goldilocks zone. You don't want your instructions to be too specific, and you don't want them to be too vague. You need them to be just right. So at one end of the spectrum, you've got prompts that are just way too brittle. This is where you try to hard code all this complex, fragile, if this then that logic directly into the prompt. The problem is, the moment the agent sees something you didn't perfectly anticipate, the whole thing just shatters. Then you've got the other extreme, prompts that are way too vague. This is when you give really high-level guidance, like be a helpful assistant. You're kind of assuming the model just gets what you mean, that it shares your context. But it doesn't, and that leads to super unpredictable, unreliable behavior. And that brings us to the Goldilocks zone, the just rights prompt. This is where you provide strong heuristics, basically rules of thumb. You're giving the model clear guidance on how it should think and approach problems, but you're also leaving it flexible enough to adapt to new situations. It's a guide, not a straitjacket. All right, next up, tools. The best way to think about designing tools for an AI agent is to treat them like functions in a really well-written code base. That means each tool should do one thing and do it well, so minimal overlap in functionality. Their descriptions and parameters need to be crystal clear. You got to design them to return information in a token-efficient way. And they have to be robust, self-contained, and able to handle errors gracefully. So we've got our building blocks down. But what happens when you have tasks that last longer than just a few back and forths? Let's get into some more advanced strategies for managing context over time. One of the most powerful concepts here is something called just-in-time retrieval. Instead of trying to stuff all the data the agent might possibly need into the context window upfront, you give it lightweight pointers instead, things like file paths or database queries. Then, the agent can use its tools to dynamically pull in only the specific information it needs right when it needs it. It's like giving it a library card instead of forcing it to memorize the entire library. But what about those really massive tasks? The ones that are guaranteed to blow past the context window, like migrating an entire code base or analyzing a huge data set. For those, we need even more specialized techniques. First up, we have a technique called compaction. The idea is simple. As the conversation gets close to the context limit, you have the model itself summarize the most critical details. Then, you basically start a new conversation, but you feed it that compressed summary at the beginning. You get to keep all the important threads without all the token-heavy clutter. Second, there's structured note-taking. This is where you actually give the agent a tool, like the ability to write to a simple text file, say notes.md. This gives the agent a persistent external memory that lives completely outside its limited attention budget. It can jot things down and then pull those notes back into context whenever it needs them. And finally, one of my favorites, sub-agent architectures. Here, you have a main manager agent that coordinates the high-level plan. But when it comes to deep, focused work, it delegates those tasks to specialized sub-agents. These sub-agents go off, do the heavy lifting, and then report back just a condensed summary of the result. This keeps the manager's context clean and focused on the big picture. Okay, so we've covered a ton of different techniques, from prompt design to sub-agents. But what's the one big takeaway? What's the guiding principle that ties all of this together? Well, I think the team at Anthropic put it perfectly. The goal is to find the smallest possible set of high-signal tokens that maximize the likelihood of some desired outcome. Let that sink in. It's all about ruthless efficiency. It's about finding the minimum amount of information that will give you the maximum impact. Every single token in your context has to earn its keep. And really, this changes what it means to be an AI builder. Your job isn't just about writing code anymore. You're becoming a curator of attention. Your most important job is deciding what the model gets to see and, just as critically, what it doesn't get to see. So the question I want to leave you with is this: how are you going to manage your agent's most precious and most finite resource?